In this video, I will show you how to interpret the SPSS output for a one-way ANOVA. This is in your packet, it's on page 4, and you can follow along. So here we have an example of reading comprehension scores by music volume. Reading comprehension scores are the DV, and music volume is the IV. To see how many levels, we can look here. Here are the descriptives. So it gives us all the descriptive information. We have 3 groups. We have low volume, moderate volume, and high volume. And we wanted to see if reading comprehension scores would differ by how loud the music was playing in the background. And so in one group they had low volume, then moderate volume, and then high volume playing in the background. And they had 3 people in each group, so 3 in the low group, 3 in the moderate, and 3 in the high group. So it gives us a total sample size of 9 people. Here we have our means and standard deviation. So these are the descriptives for each group. You have a mean and its standard deviation for all those in the low group, a mean and a standard deviation, and here we have a mean and a standard deviation. We typically don't look at the mean and standard deviation for total, so you could cross that out. And we usually don't look at this either, although we can. In this class, we won't. The next thing we need to look at is the ANOVA. If you'll notice, this is the source table that we looked at computing. And in that video, I showed you how to interpret this. Here you have the F test, and yes, it is significant. If I were to write this up, I would write it as degrees of freedom, numerator, degrees of freedom denominator 6, and our F test was 9.53, and then P is less than 0.05, and then I would have to compute eta squared. Again, SPSS won't give that to you, so you take 40.22 divided by 52.889. So why don't I show you? I can pull up my calculator here. We can do that together. So you just take 40.222. Why not go out 3 decimal points just this once? Over the total, 52.889. And that gives us 0.76. That's really high. And so that would be a large effect size. And that was 7.6. So if I had written this up, I would also have to say that it's stat sig, so get in the habit of reporting these, and I would also have to say that it has a large effect size. So it's good to get in the habit of writing those out every time we write out our F. So that would be how we write up the results. Now, whenever, like in this case, we have an omnibus F test that's significant, you have to look at what are called the post hoc analyses. And these are our post hocs. We call them multiple comparisons. This is your post hoc analysis that we discussed in the first lecture. So let's see what it tells us. Again, it's going to give us a lot of information. There are a lot of different post hocs. I ran the Tukey. The Tukey is essentially like a t-test. So we can see the differences and if it's statistically significant between every group. And even though it's significant between, all 3 groups, we want to know, is there a significant difference between low and moderate, low and high, moderate and high? And so that's what this tells us here. The first one, we can see low versus moderate. So we have low versus moderate. The mean difference is 1.33. So if we take the low versus moderate mean, we will get a difference of 1.33. And then we want to know, is that difference, the difference between 7 and 5.66, is that statistically significant? And the answer is actually no. So we'll write NS, not significant. Now, I'm going to use each of these boxes to look at one pair, so let's skip this one for now. So just go ahead down the row, and we'll just skip all of this actually. Now let's use this box, which actually has extra information, but we're just using it for one pair at a time. Now we want to see moderate versus low. Did that already, so let's cross that out. We want moderate versus high. So moderate versus high. And we want to know, what's the mean difference? It's 3.67, and we see that that is significant. It is less than 0.05. And then our final group that we're comparing is high versus low. So we can cross this one out here. High versus low, it had a 5-point difference, and that one was significant as well. So this was significant, this was significant. And again, it's just giving us the pairwise comparisons. So low versus moderate, and then it gives you low versus high, but we also have low versus high here. So again, just like most of our SPSS, gives us lots of duplicate information, but those are our post hocs. So the post hocs would say, one, the omnibus F test is significant. Overall, all these different pairs are significantly different from one another overall. But when we look at the individual pairs, we go look at low versus moderate, and we see not significant. We look at the actual means, they're not very different from one another. So that must be why they weren't significantly different from one another. Then we have moderate versus high. Well, moderate versus high, those are pretty different from one another. And how much? 3.67 points. Then we have finally our high versus low. That's comparing this versus this. That's a 5-point difference. And you see the 5-point difference here, and that is also significant. So that's important to be able to distinguish which groups are significant from one another. And that's how you would read your SPSS output for your one-way ANOVA.